Hey guys, it's Knock Me again. Welcome back. I'm going to go ahead and continue our notes for 6.1. This will be part 2. Last time we left off, right, I was quickly talking about our interpretation of the results, right? It's really important that you understand this, right? You're not saying that there's a 90% chance that the mean will be between this particular interval, right? What you're saying is that if you did this 100 times and you created confidence intervals 100 times with the same sample size but of different samples, right? And you had a bunch of different intervals. 100 of them, out of the 100 of them, 90 of them should contain the population parameter, right? The population mean, if we're looking at the population mean, right? And that's what this confidence level of 90% means. It's not that there's a 90% probability. It's if I do this a crap ton of times, 90% of these will contain the actual population parameter, okay? Now, as the level of confidence increases, the confidence interval widens, right? That kind of makes sense. If you wanted to have a 99% chance, 99% confidence level, then you could just make this thing gigantic, this interval from like 0 to a billion. You'll say, oh, I have 99% confidence that's between a 0 to a billion. But of course, that doesn't tell us anything, right? We still want to be precise with our estimate, right? And one way to do this, right, is to basically increase our sample size, right? The larger our sample size, the better our precision and our confidence will be for our confidence interval, okay? Now, here's the only problem though. How large of a sample size do we need to guarantee a certain level of confidence for a given margin of error? Of course, you could just say like, oh, just do the whole entire population then. But you know that most companies can't actually afford to sample like 1 million people, right? That's just darn near impossible, right? So what we do is we try to solve for n and see what should our minimum sample size be and still maintain our certain level of confidence, right? And we're going to do a little bit of algebra here. I know some of you guys haven't done this in a while, but you know, you guys will be okay with this. We're going to solve for n, right? When we're solving for n, we're trying to get n by itself, so then I can figure out if I keep this confidence level, right? And I have I want it to be within a specific margin of error, or within our specific E, for example, right? How large should our sample size be? Well, very simple. We just go ahead and, let's go ahead and solve this algebraically here. I'm going to cross multiply the square root of n to both sides, right? I'll show the work here, just in case you guys are a little rusty with your algebra. And I have here the square root of n times E is equal to z critical times the standard deviation. Divide both sides by E, our margin of error, and we end up with the square root of n is equal to z critical times the standard deviation over E. And to get rid of the square root that's here, all we simply need to do is take this square both sides. Right, so I end up with n is equal to z critical times the standard deviation all over the margin of error squared. Are you going to have to do this every single time? No. I suggest you just write down this equation somewhere on the side, and if I ever ask you what's the minimum sample size that you need to maintain such and such confidence level, you just go ahead and go to this equation and you simply just plug in the values that you have for your z critical, your standard deviation, and your margin of error, and then simply just do the calculations, and this will tell you how large of a sample size you need to do this problem, okay? So I'm going to go ahead and scroll down a bit here. Minimal sample size to estimate the mean. Given a confidence level and a margin of error, the minimum sample size n needed to estimate the population mean is, and like I said, write this equation down somewhere, right? It's the z critical times the standard deviation divided by the margin of error. That's it. That's all you need to do. If your standard deviation is unknown, again, you can estimate it using your sample standard deviation, but of course you need to make sure you have at least 30 in your sample, okay? At least 30. All right, let's take a look at a problem, and I'll show you. This is actually a fairly simple idea, all right? Let's say you want to estimate the mean number of friends for all users of the website how many users must be included if in the sample if you want to be 95% confident that the sample mean is within 7 friends of the population mean. Assume that the sample standard deviation is about 53. Okay, so check out the wording here, right? We're looking to see how many users must be included. That's our N. It's asking us how many people do we need to sample so that we'll still be within 95% confidence, right? So I don't know what my N is in this problem. That's what I need to find out. But there's a bunch going on here, okay? I know that my confidence level is 95%, so C is equal to 0.95, which entails, of course, tells us our Z critical, right? Looking at our chart, if I'm looking at 95% confidence level, which is 0.95, our Z critical is 1.96, 1.96 in this case. So with that confidence level, I know that my Z critical is 1.96, okay? So looking at my equation to find my minimum sample size, N is equal to Z critical times the standard deviation divided by the margin of error squared. So what I've found so far is my Z critical. I've got that. That's checked. That's done, right? The second thing I've found, another thing that I see is that the standard deviation is 53. And I already know that, well, knock me, that's not the population standard deviation. That's just the sample standard deviation, but it's okay. We can use that. That's fine as long as our sample size is greater than or equal to 30. And in this case, I'm hoping that it's going to be, it is when we calculate this, right? Now, the last thing, of course, is your margin of error. Now, you'll see in the problem, it doesn't actually give you the word margin of error, right? It just says it wants to be within 7 friends. So within 7 friends means 7 friends either above my estimate or 7 friends below my estimate, okay? So that 7 friends, that's your margin of error. That's your plus or minus, okay? That's the idea here. It's plus or minus 7, right? That's your margin of error. That's what E is in this case. E is 7, and that's what we're going to plug into this here, okay? So N for my minimum number of my sample size should be equal to Z critical, which is 1.96. Multiply that with the standard deviation of 53. Divide this whole thing by 7 and square it, right? Again, my Z critical, my standard deviation, my margin of error. And I highlighted that the wrong color. That right there. Right? And simply just take that and plug it into your calculator. So let's go ahead and do that real quick. This is going to be, I gotta make sure I put this all in parentheses, okay? Or do it piece by piece. Make sure you get it all together. So this is gonna be 1.96. Multiply that with 53, right? Take that and divide that by 7. And take that answer and square it. I'm going to square that answer of 14.84, and I get 220.23. So N is equal to 220.23. So I would say how many users must be included into the sample if you want to be 95% confident? The answer is technically 220.23, but how the heck are you going to sample 0.23? I'd say you need to sample at least 221. That's how many people you need to sample in order to keep your margin of error within 7 and still be 95% confident, right? You need to sample 221 people in order to do so, okay? All right. Let's see here. Do I have enough examples here? This is one example I want you to try, okay? You want to estimate the mean number of sentences in the magazine advertisement. How many magazine advertisements must be included in the sample if you want to be 95% confident that the sample mean is within 1 sentence of the population mean? To do this information, we're going to approximate that the standard deviation is about 5, okay? So I'm going to go ahead and ask you guys to try this problem. Again, just like before, this will be on Canvas. You'll have one place to type in your answer. And this time it's just one you try. I'm not gonna have you do the second you try for this one, but you can try it for yourself. But yeah, once you calculate this, go ahead and submit these notes. Make sure you have this answer in your notes and on the Canvas page, right? And then just go ahead and submit the notes for grading just like we've done it before in the past. And after that, your homework is right here at the bottom of your notes. Make sure you get these done. 37 through 67 is every other odd, okay? So make sure you do 37, you skip 39, and you go to 41, and keep going like that. You skip every other odd, okay? So go ahead and get that done for me. Submit these notes, right? Submit the Canvas problem as your exit ticket, and get the homework done for me, all right? And that's it for 6.1. Next time I talk to you, we'll be starting 6.2, okay? So have a good one, guys. I'll talk to you later. So long.